All right, final part. So on this whole page, when you notice all the addition and subtraction, you just have to remember that when you add and subtract fractions that you need a common denominator. And we're going for the least common denominator. So we need to break the denominators down into their individual factors so we can see that. So starting with the first one, again, I would always check to see if there are any greatest common factors. So when I look at my first one, I don't see a greatest common factor here. And in the second denominator, I can't even factor that. So I'm just going to go straight to just regular factoring. Going to erase that. And the first one is easy factoring, so I'm going to kind of speed this up a little bit. I need factors of this negative 18. Sorry. That gets me to the 7, and so that is going to be, with the regular x's, would be a 2 and a 9, and I would have to make the 9 be positive and the 2 to be negative in order to get the 7x and the negative 18, okay? All right, so next, that's what that denominator becomes, and so now when I look at it, I'm hoping at this point that you guys can see the least common denominator, and that it's this x minus 2, x plus 9. So when I look at the first fraction, it has the least common denominator, and the second fraction needs the x minus 2. So I'm going to multiply the bottom, and whatever I do to the bottom, all right, had to take a little pause there. My battery on the computer was dying. Anyway, if the bottom needs an x minus 2, then whatever I do to the bottom, I do to the top. And now my denominator is set. It is going to be this x plus 9 and x minus 2. My work now is going to come in the numerator, and I just got to clean that up. So going to the numerator only, the first fraction didn't change, but the second will be 6 times x minus 2. So I'll distribute the 6, and then I will combine my like terms. So when I'm done, my numerator after I combine this will be 6x plus 12. If they did ask about domain restrictions, I would not use -9 or 2. All right, the next one, with the second one being subtraction, I'm going to add the opposite to my second fraction. And when I add the opposite, I got to make sure that I apply it to the entire numerator. So both of these will become negative. Looking for a GCF, what I notice is in my first one, I don't have one. And then I can't even factor the second one. So I'm going to just start with regular factoring. And the first one is easy factoring. So I just need factors of negative 16. That get me to -6, and that's going to be a 2 and an 8. It's easy factoring. And I will need the 8 to be negative and the 2 to be positive. So this is done. I don't need that version. And my least common denominator will be the x minus 8 and x plus 2. So the second fraction will still need the x minus 8. The first fraction has both things. So whatever I do to the bottom, I'll do to the top. Again, my denominator is already set. My work will be all in the numerator. So the first fraction, nothing happened. The second fraction became a -x plus -5 with this x minus 8. And so I'm just going to multiply here, neighbors visiting neighbors, a lot of distributing. I'm going to get -x squared. I'll get a positive 8x. Then when the -5 distributes, I'll get a -5x. And when it distributes to here, I'll get a 40. And now, bringing down the other numerator, x squared minus 3, I'm going to combine my like terms. So my x squareds will cancel out. My x's will become 3x, and then just the regular numbers will become 37. And that will be over my least common denominator of x minus 8 and x plus 2. If I were asked about domain restrictions, I would not pick 8 or -2. And then the third one. So the third one might be a little tougher to see the least common denominator. So this would be a good time to make that table. And so when I kind of look at the first fraction, I have a 3 and I have an x to the 4th. And then in my second fraction, I have a 5 and an x. So when I just look at the x's, I need to have the least amount of x's possible. But remember, I got to build them both up. So I can build both of these up to be an x to the 4th. That will be the least common denominator. And if these were just regular denominators, what's the least common denominator between 3 and 5, then my answer is 15. So this will be the least common denominator. So my first fraction needs the 5, but it already has the x to the 4th. So whatever I do to the bottom, I do to the top. And my second fraction to get to 15, I need a 3, but I also need an x to the 3rd so I can get to x to the 4th. And whatever I do to the bottom, I do to the top. So again, my least common denominator has been established. It's 15 x to the 4th. And now all my work will be in the numerator. It'll be the 5 with x plus 7. And then just multiplying this part, I'll have 6x cubed. And now I'll just distribute the 5 for 5x plus 35 and the 6x cubed. There are no like terms that can be combined, but I'll put the numerator in standard form. So 6x cubed plus 5x plus 35. And that is number 3. All right, going to the next part, solving. So this is where we definitely need to check for extraneous solutions. So again, my goal is to find the least common denominator, and I will have to factor to make sure I get the least common denominator. In my first fraction, these can't be factored. And those two put together, the x plus 1 and the x minus 5, that is my least common denominator. So my first fraction will need the x minus 5, bottom and top. And my second one will need the x plus 1, bottom and top. So the denominator's done. Now, since we're solving, this is, again, I've pointed this out, this is like the situation where if I have 3 to the 2x equals 3 to the x plus 5, if the bases are the same, I can ignore them, and then the exponents are my problem. Well, here, if the denominators are the same, I can ignore those, and then the numerators become my problem. So I'm just going to erase this part. So I'm just going to ignore this part right here, 'cause I don't need it anymore. And the numerator is my problem. So negative 3 with x minus 5, and over here, x minus 5 with x plus 1. I'm going to clean this up, distribute my negative 3. It's a plus. Distribute over here, I'm going to get x squared plus 1x. Then I'm going to get a minus 5x and minus 5. And with more than one type of x, I'll need to get everything to one side and factor. So just real quick, cleaning up the right side, it'll be x squared plus negative 4x minus 5. And so what I'm going to do is add the 3x to join this. So I'll have x squared, and then I'll have a negative 1x, and then I'll subtract the 15 to join the 5, so then I'll have minus 20. And then this is easy factoring. Factors of negative 20 that get me to negative 1 are a 5 and a 4. And I will need to make the 5 negative. And then I'll solve. My answers are x equals 5 and x equals negative 4. So this is where I need to check for extraneous solutions. So I'm going to go back to up here and erase what I scribbled out. My denominator can never be 5 and negative 1. And if you notice, this is one of my things it can't be. So this is an extraneous solution. And on the multiple choice part, 5 is not an accepted answer. The only correct answer is negative 4. So if you saw the choices like A is 5, B is negative 4, C is 5 and negative 4, and I don't know what they would put for D, this is the correct answer because this is extraneous, and since it's extraneous, it's not considered a solution. Okay? All right, let's move to, whoops, sorry about that. Let's move to the next one. So on number 5, again, I would look at my denominators and I would try to factor them. I can't. And my least common denominator will be the x with the x minus 5. So when I look at my first fraction, it needs the x. So whatever I put on the bottom, I put on the top. The second one needs an x minus 5. Whatever I put on the bottom, put on the top. And the last one needs an x. So now, just focusing on the numerators, because since the denominators are all the same, I can ignore them. I'll have 4x from the first fraction. I'll have 1 times x minus 5 from the second fraction, and it's going to equal x with x minus 1. So I'm going to distribute the 1, which just keeps it the same. I'll distribute the x over here. And now with more than one type of x, I'm going to get everything to one side. And to keep it easy factoring, I'm going to keep this over here so it stays positive. So real quick, the right side is 5x minus 5. It's a minus. So I'm going to subtract the 5x to join this negative x. That'll be negative 6x. And I'm going to add the 5 over to the other side. And now I'll be looking for factors of 5 that get me to -6. It's easy factoring. These are the only factors of 5. And I'm going to make them both negative so I can get the positive 5 and the -6. So when I'm done, my answers are 5 and 1. And again, going back to the top up here, my denominators can't be 0 or 5. So this 5 is considered an extraneous solution. The only real answer is the 1. So our last one in this section is number 6. And I will have to do some factoring here. This one, which is the same as this one. This is just easy factoring. Factors of -8 that get me to 7 are going to be a 1 and an 8. And I will be making the 1 negative. So cross this off, same thing here. And so the least common denominator is this a plus -1 and a plus 8. So my first and my last fraction are good. The second fraction is going to need the a plus -1 or a minus 1, however you want to write it. So I'm going to write it as a minus 1. And whatever I do to the bottom, I do to the top. And now since all the denominators are the same, I'll ignore them and focus on the numerators. So I'll have 1 plus 7 with the a minus 1 equals 5. Distribute my 7. I'm just going to combine those real quick. 7a minus 6. And now to get a by itself, I'm going to add the 6 over. That gives me 11. And then I'm going to divide by 7, so my answer is 11/7. So now your job is to try the next section on your own. Okay? And then again, don't forget to check for extraneous solutions. All right, last part is graphing. So how many do we have here? We have 2 as a graph, as a class. So we're going to try those as fast as we can. So normally we've always made our t-chart, and we're still going to use the points -2, -1, 0, 1, and 2. And a parent function in rational functions is 1 over x. But in this case, we are going to use the -4 over x, and we are going to build in the stretch that comes from the 4 into our t-chart, and we're going to build in the flip already. And I'll deal with the -5, which will be a right 5, and the up 1 once I get my t-chart done. So putting in my points. So if I put -2 into here, I get 2. If I put -1 into here, I get 4. 0 doesn't work. If I put 1 in, I get -4. And if I put 2 in, I get -2. So again, I build the stretch and the flip in. And I have a wall. In this section, I have 2 walls. I have this one and this one. And remember, they are both affected now. So I'm going to take my wall and I'm going to move it, let's see, right 5. So it's going to end up here. And up 1, and it will end here. And now I'm going to treat that as the x and y axis and graph -2, 2, -1, 4, etc. So here is -2, 2, -1, 4. Sorry, that wasn't -2, 2. Let me fix that. -2, 2, -1, 4. And here's my first one. And then I'll graph 1, -4. And 2, -2, and here's my other shape. Remember, they are diagonal or catty corner from each other. And now I'm going to do my x's. So the way I suggest you do these is you take the left and the right first. It's going left, so that's -infinity. It's going right, so that's infinity. And then you tackle the up and down. The up and down are the y's, so I'll get the x in a moment. So it's going up, infinity, and down here it's going down, so -infinity. And if you get the walls in there, one wall is x equals 5, the other wall is y equals 1, then whatever number you're missing over here will be one of these walls. So on the left and right ones, I'm missing the y because the y's are going down, but they're getting stopped by the wall, and the y's are going up, but they're getting stopped by the wall. And then the x's, they're going to the right, but they're getting stopped by the wall of 5. And then they're going to the left, but they're getting stopped by the wall of 5. And then I can do my domain and range. So my domain is -infinity to 5, and then back from 5 to infinity. My range is, let's see, -infinity to 1, and then 1 to infinity.